Welcome to the EuroMaito project webinar. Today we have a talk about extended lactation. And the talk is given by Jesper Lehmann, who is from Aarhus University, and he has made his PhD thesis on this topic. And I'm your chairwoman today, and I am from Savonia University of Applied Sciences, working here as a principal lecturer. Please, Jesper, tell us about the interesting topic.
Thank you, Heli, and thank you for the opportunity to present some of the work that I and my colleagues have done over the past few years. Just briefly, I have a master's degree in animal science from University of Copenhagen. I since finished my PhD in the topic of extended lactation at Aarhus University 2 years ago, and it's from this project that I will be presenting today. I'll be presenting work that I have done myself and some of the work that my colleagues have done within the same project. I'd also just like to mention that before I went into all this academia, I have I grew up on a dairy farm, and I've worked in various parts of the dairy industry in Denmark. So it's not completely out of touch of what farmers are actually working with today. But I would like to begin my talk with a little story. And what you see here is a Jersey cow, and her name was Yrsa. And the story begins when this cow was 3 years old, and there was a guy, he purchased her because she was actually on her way to be slaughtered. But he buys her, and he buys a bull calf. And then he brings those two with him to his small island where he lives. And this bull calf drinks milk from Yrsa, and he gets the rest for his household. Following spring, he slaughters this bull calf, and he buys a new bull calf, and then this just continues. And when this picture was taken in 1993, this had occurred for 22 years straight. So this cow has actually been producing milk for 22 years without giving birth to a calf of her own. She is then 25 years old at this time. And it continued for another 2 years after this photo was taken, and they only stopped milking her because the owner died. The next one here is a figure from a study from the United States. And it's, as you can see on the bottom here, it says 1887, and that is actually not a mistake. Back at that time, they actually looked at the ability of cows to produce milk for an extended period of time. If you look at the blue curve, that's the milk yield, and then you can see the level on the left-hand side. So, of course, it is small milk yields, but this is 130 years ago from now. The red curve shows that the percentage of cows milking at a given point of time after calving. That's the days in milk you see at the bottom. And it showed that actually there are some cows that were able to milk for what was an extended period of time 130 years ago. So, but before I sort of delve more into this topic of extended lactation, I'd like to sort of give a more introduction to what we think of as an extended lactation. And when we talk about extended lactation in comparison with the traditional lactation, we mean the lactation is extended by choice. So it's a choice that this particular cow has not been inseminated, and it's not because of a failure to conceive. And just to sort of illustrate this concept a bit more in detail, well, we have traditional lactations with a calving interval of 12 months, a dry period of 2 months, and then a lactation period of 10 months. We would have 3 of these cycles in a 3-year period of time. And thus, this average cow would then be dry for 2 months per year. If we then went on to an extended lactation scenario where there would be 18 months between calvings instead. We would then go from 3 dry periods in 3 years to 2 dry periods in 3 years. And on average, we would actually convert 3 weeks of dry period per year into a time where this cow produces milk. But as you can see here, I have just taken this lactation curve. So that's this orange curve that shows the level of milk yield after calving until dry off. And the characteristic is that it increases, peaks, and then decreases. And what I've done here is I've sort of stretched the curve a bit. And it means that these curves become flatter. But this might not necessarily be so. I mean, you might wind up in a situation where you don't stretch the curve, but you just extend it, which means you will wind up with some cows with very low milk yields. These are some of the issues that I will get back to at a later point in this presentation. Good. But the whole idea here is that if you went from 12 months to 18 months, you could actually convert 3 weeks of non-production period per year to production period. And of course, this is just 18 months as an example. I mean, 13 months would also be extended compared with the 12 months. So, but the whole idea of extended lactation actually arose from an observation already in the 80s that our cows were beginning to produce a lot more milk yield. That's what you see on this figure here. You see through breeding, we've actually increased the milk yield by a lot upwards, which means when we arrive at a drying off time, we have cows that today are producing very high milk yields, and it's quite stressful for the cow to be dried off and then have to reinitiate this milk yield 8 weeks later. So that was one of the issues. The other issue was that we've seen a declining fertility in dairy cows over the past 30 to 40 years. And that has been related to the negative energy balance of dairy cows. And the negative energy balance is a result because these cows are also from nature not able to consume enough feed in the early part of the lactation. So they're taking nutrients from their bodies and then using those to produce milk. That has increased over the years. So now these cows are actually have more severe negative energy balance, and it goes on for a longer period of time. And that has a negative effect on these cows' ability to conceive. So the idea with extended lactation was then to just inseminate these cows after this is all done. And then if you look at sort of more of like the logic behind the extended lactation, and if you go with extended lactation in your dairy herd, you're going to have fewer calvings per year. If you have fewer calvings per year, you're also going to have fewer calves and you're going to have fewer heifers. So your same dairy herd, if you have the same total number of dairy cows, you'll have fewer young stock to rear. Also, you're going to, as I said, convert some of the dry days to production days. But you might also have a derived effect of fewer diseases per year, because 2/3 of all diseases in dairy cows actually occur around the time of calving. And hence, you'll have fewer diseases if you have fewer calvings per year. But this was sort of the background for when we started the project we call REPROLAC. And it was actually a bigger project. There's a website here that you can go and have a look at if you like. But we did on-farm experiments, and we did some experiments at our own research station. We've looked at animal health and longevity. We've looked at milk quality. We've looked at reproduction, climate, productivity, and economy. And these are some of the things that I will go through in my presentation. And we'll begin with talking a bit about reproduction and heat detection, a bit about milk quality. Then I'll talk a bit about the 4 farms that we enrolled in our project, that were the private farms that were testing this out for us. Something about milk production, something about selecting the cows, because it seems like there's not every cow is able to do this in a good manner. Then I'll move on to talk about farm economics, some greenhouse gas emissions, and then finish off with discussing some of the possibilities and challenges that lies within the use of extended lactation in practice, and then come up with a recommendation at the very end to how could you, as a farmer, actually start this in your own herd. So we did a study on reproduction in heat in our experimental herd. So this is a place where we have very sort of intensive knowledge of these cows, and we have intensive monitoring. And what this figure here shows is the daily activity of cows from the 4th estrus until their 8th estrus after calving. So this is actually over a very long period of time, if we have 3 weeks between each estrus. And this shows that the daily activity of cows, the normal daily activity of cows actually declines over lactation. That's the bottom part of this curve. And it shows that the extra activity due to estrus declines over time too. That's the gray part. That's what you would normally record, or what would be part of what you would record with activity monitoring devices, like you put on the leg of a cow or in the neck collar. The black part here is the activity due to mounting, so that the cow jump on top of each other, basically. You would record with activity monitoring devices too. But the interesting part here is that this level of activity, or the difference in activity of a cow in heat and not in heat, is the same throughout the lactation. So it actually allows these activity monitoring devices to work irrespective of how far from calving you are with these cows. The next one here shows the level of the change in milk yield and milking frequency relative to the day of estrus. The day of estrus is day 0 that you have here. This is in a robot herd. And it shows that milk yield from these cows when they're in estrus actually declines by about half a liter a day, or half a kilo a day on the day of estrus, and then recovers afterwards. But because they have an increased milking frequency actually up until the day of estrus, you won't see that there's a loss in milk yield in your milk tank. You will just move it to a different day, basically. Another study we did in the research herd and on the private herds is we looked into the milk quality of these cows, or the milk during the extended part of the lactation, because there were some old stories about poor milk quality in late lactation of extended cows. But when we looked at the milk quality in the later part of the lactation, in the experimental station, we actually saw some good sensory quality of this milk, and we saw some good cheese making properties as well. In the private herd, we looked at the difference between those cows that were on a long lactation and on a short lactation, and we actually saw there were no difference in sensory quality, and we saw no difference in cheese making properties. So this, in summary, we cannot see that there should be any concern at all about this milk from the late lactation. So now I'd like to sort of just briefly introduce the 4 herds that we used for our experiment. And you'll see from this table that there's 4 very different herds. In fact, the herd 1 is an organic herd, and herd 1 is a conventional herd, and herd 2, 3, and 4 are organic. But that's not by our choice. These are the herds that we could find that were consistently managing cows for extended lactation. You see 2 of them have Holsteins, 1 has a cross herd between Holsteins and Jerseys, and the 4th herd is only Jerseys. You have 2 robot herds, and you have 2 herds with cubicles and 2 with deep litter bedding. The only thing they have in common is that they only feed 1 TMR or a PMR mix if they have a robot for concentrate feeding. So they don't differentiate feeding in relation to how far these cows are from calving, or if they're on extended lactation or on a traditional lactation. which is good for a study like ours, so to speak. We have two sort of relatively high yielding herds, about 10 and 12 tons of milk per cow per year, and then two herds with just a little less than 8 tons per year. This slide shows a bit about their sort of approach, these farms' approach to extended lactation. For example, you can see the herd 1 considered a short lactation to be 13 months. In some places, that would also be an extended lactation. Herd 3 said that, well, a short lactation for us is 15 months, but a long lactation for them was 18 months. And you can see that for herd 1 and 2, they actually selected 97 and 82% of their cows for extended lactation. And when we talked to them, they said, well, we always say that every cow can do extended lactation, and then there are some that cannot do it anyway. So their sort of starting point is that every cow should have an extended lactation unless something says this cannot work for this particular cow. And when we asked them, so what were the reasons that you would look into saying that this cow could not do extended lactation, they mainly looked at milk yield in the previous lactation, if that was available, or in the early lactation. I mean, if these cows were actually had a good start of their lactation. They also looked at body condition score and health. So some of the variables that would normally look, we would use as indicators if this cow would be able to complete the lactation and not either die on the way or be cold. So the first thing we looked at was milk yield of these cows, and we started out by looking at the average milk yield per feeding day, and then had that in relation to how long these calving intervals were. And when we look at it per feeding day, we just have to be aware that that's the total number of days between two calvings. So a feeding day is also a dry day. So, I mean, if you take the total time between two calvings, you'll have some lactation days and you'll have some dry days. But the milk yield that this cow produced during the lactation is also going to have to pay for feeding this cow during the dry period. So we take this total milk yield and then divide it by the total number of days between two calvings, so including the dry period. And when we then looked at this, we saw that these cows, and this is older cows, so this is third parity or higher, we saw that, excuse me, that the average milk yield per feeding days was actually unchanged during this lactation, irrespective of how long these calving intervals were. Obviously, as we can see by the black bars, there's a big variation in this, and I will come back to that later on. But the average cow actually produced the same amount of milk during their completed lactation. We also looked at the milk yield towards drying off, and the longer the calving interval, the lower the milk yield was at dry off. And I mean, that's a situation we actually wanted. We wanted to be able to dry these cows off with less milk yield. And the reason why this works is that the time period where where cows don't produce milk, so the dry period, the effect on that during when you divide the total lactation yield between the feeding days becomes less. So you dilute the effect of the days where the cows don't produce milk. So that way you can have less milk in the beginning, in the end of the lactation, and still maintain the same milk yield per day. We also looked at what would be the level of milk yield in the early second lactation of a dairy cow if the first lactation was extended. So this looks at the length of the calving interval of the first lactation and then the starting yield of the next lactation. And this shows that the longer the first lactation was, the more milk these cows produced in the beginning of the second lactation. And you can sort of explain that by these cows being able to have more time to grow in the first lactation, so they're more fully grown in the second lactation, and they don't have to spend so much energy growing, and they can focus more on producing milk instead. And then after this, we looked a bit into sort of, can we somehow find a way to select or predict which cows are going to be able to produce milk for an extended period of time. And what you see here is a calving at, so if we take it from the beginning from the left side, you have a first parity cow that goes through a standard lactation. You have some milk yield available here, or some milk yield information available, and then the cow produces another calf, and you have some starting milk yield available, and then at some point you have to make a decision: should I inseminate this cow now, or should I wait? And that decision is then inevitably going to depend on what is my expectation for the level of milk yield during the rest of the lactation. Is it an average cow that produces an average level of milk yield? So maybe it's good for extended lactation. Or maybe it's a better than average cow that has a very flat lactation curve, so it's good for extended lactation. Or maybe it has a very steep decline in milk yield, and perhaps this cow should not have an extended lactation. So how could we predict this? That's sort of the question we asked ourselves. And unfortunately, the only thing we could sort of correlate here was actually the milk yield available from the previous lactation and the milk yield in the early lactation. Those were the only things that actually were able to predict the milk yield later on. I mean, we had knowledge of the body condition score and the health of these cows and the welfare and whatnot, but none of these actually said much about these cows' ability to produce a high level of milk yield later on. So I will get back to this when I discuss the possibilities towards the end, but only milk yield were actually good levels predictors here. But I would just want to make one more comment, and that's, you just have to be aware, how do we define a successful extended lactation? Is that a cow that produces a lot of milk yield during the extended lactation? Or is it a cow that is able to produce well in the following lactation? I mean, if you have a long lactation, this cow becomes fat. So maybe it did well during the extended lactation, but because it's fat, it may do not so good in the next lactation. This is a point I will get back to later on. So before I talk more about sort of the economics and the greenhouse gas emission and the productivity of extended lactation, I just want to have a comment here on how do we actually approach this. And if you look at a dairy farm, you have a lot of dynamics going on. You have these, and I mean, you have cows that are they're lactating all the time. You have dry cows. You have the calves and the heifers, and you have these moving around in cycles. You're selling bull calves, you're selling cold cows, you're selling milk. You're using a lot of feed to feed this herd. Some of it may be produced on the farm, and some of it may be bought. And the point with this slide is to show you that these are sort of the dynamics that every farmer is dealing with on an everyday basis, because they're dealing with all these cows and they're dealing with all this feed. And we actually handled all these dynamics when we looked at the economics of extended lactation and the greenhouse gas emission. So it's just to sort of illustrate that we try to sort of look at this from a farmer's point of view. We created some different scenarios for extended lactation. And we compared it with the baseline scenario where with a calving interval of 13 months. That is the average in Denmark as we speak. And then we had two scenarios where all cows would have extended lactation, So they would either have calving intervals of 15 months or 17 months. 2 scenarios where we only extended first parity cows, and 2 scenarios where we only extended the older cows. So sort of illustrate what would be the effect of only selecting some of these cows for extended lactation. When I show you some of the results, I will focus on the baseline scenario and then the scenarios where we have calving intervals of 17 months as extended. Yeah, I think I'll skip this because we have running a bit out of time here. So to begin with, first we looked at the productivity of these cows, and our baseline scenario is average milk production of 11,000 kilos per cow per year, which produces an average of 132 kilos of meat. So that's the cull cows, it's the bull calves, it's all an aggregated way of looking at what is the meat production here. And then if we look at what happens during these different scenarios, I should say these are index values. And if it's red, also for the later slides, it's less. If it's blue, it's the same or more. And we look at milk yield. If you have all cows for extended lactation, you're going to lose about 4% of milk yield, of your milk yield, in our simulations here. If you only extend first parity cows, you're going to maintain roughly the same amount of milk production, because these first parity cows generally have a very flat lactation curve. But all 3 of these scenarios, you're going to have a lot less meat production. And you can somewhat convert this to the number of young stock. So if you extend all your cows to have calving intervals of 17 months, you're going to have around 25% fewer heifers to take care of. I should say that these simulations, we were not able to account for a change in the negative impact of pregnancy on milk yield. It is actually such that then pregnancy itself has a negative impact on milk production. And if you extend the lactation, we should actually postpone this negative impact. But in the simulation models that we have for dairy farms, this is not implemented yet. So you can say that this 4% reduction is actually a bit sort of pessimistic in a way. So it's, I guess, worst case scenario, you could say. We also looked into the resource use of these cows. And if you look at feed use for the cows, you have about 8 tons of dry matter per cow in our baseline scenario, or 10.5 tons of dry matter if you include all the young stock. You have 200 kilos of nitrogen excretion per cow per year, and you need about a little more than 1 hectare of growing land to grow feed for these cows. We import about 20% of the feed onto these farms, so it's only the protein feed that's imported and some minerals. And I should just say that we actually balance these rations for each individual scenario. So again, if you look at these index values, we see we actually don't have much change in the feed use for these cows. But we also still have the same number of cows. Where we're really saving feed use is for the young stock, because we have fewer young stock. For example, if you have all cows for extended lactation, you could save about 7% of feed use on your dairy farm. So you have to include the young stock here. And that translates more or less directly to fewer nutrient excretions from this herd, and a less requirement for land to grow feed. I mean, again, if all cows have set calving intervals of 17 months, it's about 14% of land use that you actually save. Again, so if we move on to look a bit more into efficiency, you can calculate the milk production efficiency per kilo dry matter if you only have the cows feed use, or if you have the whole herd. And I mean, the reasoning for including the young stock in this calculation could be that these young stock are actually required for this milk production to continue going forward. And if you look at this, if you extend lactation for the cows as such, you're going to see a little reduction in efficiency. But if you look at the overall herd efficiency, you're actually going to see an increase. So that's when you actually account for you need fewer heifers to have the same milk production. And in fact, if you look at the land use that you have on your farm, you might actually end up with a 12% increase in energy production per hectare if you have all cows on 17 months. So we looked at a bit into the economics of this, and these are in euros per cow. And I'm not going to go through every number here. And these are actually euros, so not the index values. So you can have a look at these slides afterwards. But what we looked at is the revenues, so milk production, sale of milk and sale of cows. We looked at the feed costs, the diseases, reproduction, and some other costs. And if you look at this, at the total expenses, it's about 2,000 euros per cow in the baseline scenario, and about 4,100 euros in revenues. So you see across these scenarios here, we have a reduction in revenues. The reduction in revenues is a bit smaller for the first parity cows, and we have a reduction in expenses. And if we divide these two, we look at a contribution margin. And we actually see that we have, 47 euros per cow per year in loss if all cows are going for extended lactation, whereas we have a small gain if we only extend the first parity cows. And I should then say that some of the expenses we did not account for was labor costs, and if you account for that, it actually becomes profitable to have all your cows for extended lactation too. And the reason for not including that is that some farmers are working there themselves. I mean, it's not hired labor. So you can say they're not paying directly for labor. And then if you look at these are just the percentage changes. So if you look at the price sensitivity, for example, a 15% change in milk price actually changes this contribution margin with 25%. So 570 euros. So the difference, the effect of extended lactation on these results are actually much less than the effect of changing milk prices, just for comparisons. Oh yeah, and then I used the milk price of 34 euro cents per liter. But if you remember a few slides ago, we actually saved some land. And we saved some, we don't have as many young stock anymore. So this land, you could either use that to grow a cash crop. Here it's exemplified with barley. Or you could use this land to grow more, to feed more cows. And in some dairy farms, both young stock and the cows are actually in the same barn. So perhaps it's just a matter of moving one gate, and they can use some of the space they saved where they don't have young stock anymore to have more cows. And if you then look at the economic impact of this, you could actually gain an extra profit from growing barley of 119 euros per cow per year if all cows are extended for 17 months. Or 138 euros if you can have more cows. And then if you add that to the contribution margin, and this is not including the effect of labor cost, because you would actually you do save some labor when you have fewer cows to rear. So you have that labor to either grow more cash crops or feed more cows. You actually wind up in a situation where you can gain around 100 euros in your scenario with all cows for 17 months carrying intervals. So this just illustrates that you need to sort of be very careful with where the effects actually arise when you extend the lactation of the individual cow. Are you able to actually harvest this gain or these saved costs or these saved benefits? I mean, if you have less land requirement, maybe this is also an expensive rent contract that you can then have to get rid of and then save some money in that respect. Yeah, the percentages again. So we then moved on and looked into sort of the effect on greenhouse gas emission. And if we look at it on an annual cow basis, we actually see some fairly significant reductions in greenhouse gas emission, because we don't have that many young stock anymore, and these cows are able to milk for longer. But because we also have a reduction in milk yield, and we account for that, we're going to have the same level of greenhouse gas emission per kilo of milk. So it's not a benefit in that respect, but only per cow. So it depends a bit on your perspective on greenhouse gas emission here. But then again, what if you, instead of using that freed area to grow a cash crop, you used it to grow an energy crop? You could then further reduce your greenhouse gas emission if you wanted to. And finally, we looked at eutrophication and the total land use, so including the feed that you buy in, ammonia emission, and biodiversity loss. And we see somewhat the same effects as the CO2 emission per cow. So we actually see some, but they're although smaller effects, so some small benefits for eutrophication and land use, ammonia emission, and biodiversity loss if you use extended lactation. But then again, if you remember from the first slide of this, it was more likely a sort of pessimistic approach to what would the level of milk yield be at the end of these lactations. So if you have an improved persistency, this would, at the end of the day, likely actually improve these results. So actually further have improvements. So this is the second to last slide that I have. I just want to mention some of the possibilities and challenges if you want to do this in practice. And if you're going to use extended lactation in your own dairy herd, you have to be aware of these saved costs. So the saved costs for reproduction, you don't need as many inseminations. These saved costs for the veterinarian, saved labor costs. I mean, are you able to realize these as a dairy farmer? I mean, are you able to feed more cows? Are you able to grow a profitable cash crop on this land? Or is it an expensive rent contract? I mean, these are the considerations you need to account for if you want to look at, if you want to go into extended lactation. And, what is actually the persistency of my dairy cows? Excuse me. I mean, do I have cows that are very persistent, that they're good at maintaining a high level of milk yield? And maybe they're good for extended lactation then. Or maybe if my cows have sort of very steep decline, so they're not good at maintaining milk yield, perhaps I should not do extended lactation then. And also, think about maybe I can feed these cows differently. Maybe if I have the ability to group house my cows inside the barn, so I can have the late lactation in a different group, so I can feed them sort of more specific for their needs, and then maybe optimize that situation a bit. And then again, if you look into selecting these best cows for extended lactation, then look at the individual cow and see, is this a cow that performs relatively well in my herd compared to other cows in this herd? And then finally, avoid problems with multiple heats. If you do extended lactation, you're going to experience more cows in heat running around in your herd. So if you have a dairy barn that's small and you have many narrow corners, or if you have slippery floors, maybe it's not so good to have many cows in heat running around in there, because you're going to risk some of these cows becoming injured. But if you have a spacious barn with lots of space, and you have a good environment where they can actually express their behavior, or maybe separate these cows that are in heat, perhaps it's okay for you to handle these multiple heats. The 4 farmers we worked with said that they actually did not have an issue with this problem. And then the last one here I want to sort of talk about is fat dry cows. It's always a problem that I hear about when I talk about extended lactation. And when we looked at these 4 dairy farms, we saw that the length of the lactation, the longer the lactation was, the higher the body condition score was at dry off on all 4 herds. The red line here is the Danish recommendation for dry off body condition, and the blue line is the American recommendation. So we don't have huge problems on these 4 herds, but we saw, cows did become fatter towards the longer the lactations were. So it's something you as a farmer have to be aware of. And it speaks to the idea that maybe you should actually consider housing the late lactation cows separately so you can feed them a less energy intensive ration, which would also be cheaper. So my final slide here is, if you want to do this at home in your own farm, I would start by selecting high-yielding persistent cows. I would try to look at, so if I could reduce the feed energy concentration in late lactation. I would begin with first period cows. In all the analyses that we've done, you as a farmer have less risk of something going wrong if you start by extending first period cows. And again, check your ability to realize these saved costs. And then I generally tell farmers, if you want to test it out, just begin by selecting 10 of your highest yielding first period cows. You don't need to do any investment. You don't need to go and buy anything to do this. Select 10 high yielding first period cows and try it out, see what happens. You might have to slaughter one of these cows if it goes bad, or you might have to have an extended dry period for these cows. But your risk is relatively small. And then remember to follow up on these 10 cows to actually monitoring them to see what happens. And with that, I will just thank you for your attention. And this is some scientific articles you can look at if you like later on. So thank you for your attention.
Thank you, Jesper, for very, very interesting talk. I hope we will have many cows like Yrsa in the world.